In this study, we examined whether our population of flies followed Hardy-Weinberg equilibrium over multiple weeks. We tracked changes in phenotype frequency for wild-type and vestigial traits in fruit flies. Using observed and expected genotype frequencies, we performed a chi-squared test to determine if evolutionary forces were acting on the population.
We recorded an increase in wild-type individuals and a decrease in vestigial individuals. Our expected values were calculated using the population proportions from week 1. By comparing our observed and expected values, we conducted a chi-squared test to see if the changes were significant.
We used the chi-squared test formula, and for wild-type individuals, the value was 0.499, and for vestigial individuals, the chi-squared value was 4.335. The chi-squared total value was 4.834. Since our chi-squared results was greater than the critical value of 3.84, we reject the null hypothesis. This means that population is not in Hardy-Weinberg equilibrium and that there is an evolutionary force that is influencing allele frequencies.
So our results indicate that this population is undergoing evolutionary changes, and the significant chi-square results suggest factors like natural selection, genetic drift, or non-random mating may be influencing allele frequencies. So what we learn is that Hardy-Weinberg equilibrium is not always maintained in real populations, and then small deviations in expected frequencies can indicate evolutionary forces at work. And so what we'd do for the next step is that we would increase our sample size and replicate the same study across more generations to help validate our results. And then a piece we would change is how we would start with a much more higher number of the vestigial flies compared to the wild type and see if we conduct the same outcome. And so our specific violation of Hardy-Weinberg equilibrium was that we had a small population, and a small population violates Hardy-Weinberg equilibrium and causes genetic drift, which causes random fluctuations in allele frequencies, which ultimately ended up affecting our observed compared to our expected. And the reason that we ended up with more wild-type phenotypes is because of the small population.